Hi, kitties. It's Grandma Marnick. Your school teacher isn't here today, so I'm gonna help you with your mathematics today. I don't really know much about how you do this boxing division and this discoing multiplication, but we're gonna do fractions today. So follow along with the directions in this video. Show you how to do problems like you'll see on practice 11-5, number lines and equivalent fractions. I'm going to underline equivalent. That means equal or the same. The directions say write two fractions that name each point on the number line. So for 1, 2, and 3, I have 1 point, but it wants us to write two fractions. So that means I'm going to need to find an equivalent fraction. So the first thing I do, looking at number 1, is I'm going to circle my holes, 0 and 1. All of my tick marks are between 0 and 1. First, I'm going to find out my denominator by counting the swoops in a low denominator voice. 1, 2, 3, 4, 5, 6. So I know my denominator is going to be 6. So I'll put over 6, over 6, over 6, all the way down the line. Now I can count my numerator in a high voice. Ready? This one is right here at 0, so that becomes a 0. Then I count. 1, 2, 3, 4, 5, 6. And that makes sense because my last one at the 1 is 6 over 6, which I know is 1 whole. Okay, so now I know that the point is 2, 6. So I'm going to write that on my line. But don't forget, our directions say to write two fractions that name each point. That's only one fraction. So I know to make an equivalent fraction, the easiest, fastest thing I can do is to multiply by 2 over 2. So 2 times 2 is 4, 6 times 2 is 12. So an equivalent fraction to 2 6 would be 4/12. Let's try it again on number 2. First, circle the holes, 0 and 1. All of the numbers, all of the points on my number line are between 0 and 1. Now I'm going to count to find my denominator on the bottom in a low voice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my denominator is going to be 10. So this time, there's a lot of points here. I'm just going to write it for my point because the directions don't tell me to care about all these other points. I just need this one. So I'm not going to waste my time by writing every single one. I am still going to count my numerator, but I'm only going to write it for the point that I need. So count with me in a high voice. Ready? 0, 1, 2, 3, 4, 5, 6, 7, 8. Don't forget to write it in. 9, 10. And that would make sense because that would make this 10 over 10, which would be equal to 1. So I know my point is at 8/10, but the directions say to write two fractions, I only have one. So I'm going to take 8/10 to make an equivalent fraction. The easiest thing I can do is multiply by 2 over 2. 8 times 2 is 16. 10 times 2 is 20. And I get an equivalent fraction of 16/20. Let's do one more. Number 3. Circle your holes 0 and 1. Count to find out your denominator in a low voice. 1, 2, 3, 4. So I'm going to put my denominator, I'm just going to put it right at the point that is important to me, the one I care about. It's going to be over 4. Now I can count my numerator in a high voice. 0, 1, 2, 3, 4. And my point is 2/4. But I need two fractions, so I take 2/4. The easiest way to change it into an equivalent fraction is to multiply by 2 over 2. 2 times 2 equals 4. 4 times 2 equals 8. My equivalent fraction is 4/8. You know, when I was your age, we didn't have any of these cell pads or
Padlets or keyboards or any of this tech stuff or electronicals. If our teacher wasn't in school, one day we just sat there. We didn't get to watch a video. Wow.
We're still looking at practice 11-5, but this time it's giving us 3 fractions that it wants us to put on a number line. We can still do this. We follow the same steps. Nothing changes. We circle our wholes, 0 and 1. We find our denominator by counting our swoops in a low voice. 1, 2, 3, 4, 5, 6. So my denominator is going to be 6. So in every box I'm going to put over 6, over 6, over 6, and over 6. I can see here that this one isn't over 6, it's 1/2. So I'm going to come back to that later and check to make sure that I did it correctly. So let's go over and see what the fractions they want us to write on the number line is. The first one is 4/6. So I'm going to need to count. 0, 6 is right here. 1, 2, 3, 4. 6 would be right here. So now I put 4 6 on. Now I need to put 1 6. So I count again. 0 6. 1 6 would be right there. Then finally 2 6. It's going to be after my 1 6. 2 6. And it's in red because for some reason that one is special and I didn't change my color. Okay, so I need to make sure that this makes sense though. I have 1 6, 2 6, then 1/2, the denominator changes, then 4 6, and then I know that this one here would be 5 6, but it didn't ask me to label that, so I really don't have to. But I need to make sure, does this 1/2 in the middle, does it make sense with the rest of my work? So I need to take 1/2 and I need to change it into a 6. So 1/2, 2 times what gets me to 6? Well, 2 times 3. So I need to multiply by 3 over 3. 1 times 3 equals 3. And I get 3 6. Now, let's check and see if that makes sense. 1 6, 2 6, 3 6. 4 6 and 5 6. So it does make sense. 1/2 equals 3 6. So I know I'm good. Looking at number 5, it wants me to put 5 6, 3 6, and 2/3 on my number line. Now I already see I have 2 fractions that have the same denominator and one that's different. So I'm going to have to do something to change that. But my steps don't change. I circle my wholes, 0 and 1. All of my boxes are going to be my fractions. So I'm going to go ahead and count my denominator in a low voice. The denominator. 1, 2, 3, 4, 5, 6. Ooh, that's a funky looking line there. Let me fix that. Okay, so my denominator for all of these is going to be 6. So let's look at the ones it wants me to do. Remember, this is going to be 0 6, this is going to be 6 6, or 1 whole. So the first one it wants me to put on is 5 6. So I'm going to count up to 5. 1, 2, 3, 4, 5. My 5 6 is going to go right there. Then it wants me to put on 3 6. So I count 1, 2, 3. 3 6 goes here. Then it wants me to put on 2/3. Well, my denominator is in 6th, so I'm going to have to change it. And I'm going to write down here 2/3 times, and I'm changing it to something over 6. 3 times what equals 6? 3 times 2 equals 6. So I can multiply by 2 over 2. 2 times 2 equals 4. So I know 2/3 is equal to 4 6. So I'm going to find the spot for 4 6. 1, 2, 3, 4. 6 is going to go right there. But really, it's not 4 6. It wants us to put 2/3. So I'm going to cross it out and write 2/3. So I put it in the way that they told us to, because we want to make it match. Now they didn't tell us to put the other numbers on the number line, but we would just know that this is going to be 1 6, 2 6, and that fills it in. All right, that's all I have for you. Good luck with those fractions and number lines. You're doing great.
Listen up, Sonny. You better be doing your studies for your teacher. You better be doing your arithmetic and all that and getting good figures and good grades. Are you listening to your teacher? You better listen to your teacher.
Okay, let's look at number 6. It wants us to find out which of the following pairs are not, put a box around not, equivalent fractions. So we know equivalent fractions are fractions that are equal, and we're looking at fraction pairs. Remember, pairs means two, like a pair of shoes. So we're looking at our choices, A, B, C, and D, to say which pair are not equivalent. When we're comparing fractions, we can only tell if the pieces of pizza are the same size if our denominators are the same. So when I'm looking at 1/3 and 5/8 for choice A, I can see I have 3 and 8. The pieces are not cut into the same size. So I'm going to need to change the denominator to make it something that is the same. So you don't have a lot of room on your worksheet to do your work, so either write itty bitty teeny tiny small right next to A, or flip to a different page in your packet where you can show your work. And we're going to write 1/3, and underneath it we're going to write 5/8. We need to change the denominators to make them the same. To do that, we can multiply the denominators together to get a common denominator. So if we look at 3 and 8, we know tree times skate equals dentifloor 24. So I can change both denominators to 24, and then I'll be able to compare the same sizes of pizza because the denominators are the same. So I need to figure out 1/3 times what will get me something over 24. I know tree times skate equals dentifloor 24, so if I multiply by 8/8, or 1 whole, I know 1 times 8 equals 8, and like I said before, tree times skate equals dentifloor 24, and I get 8/24. Now I have to make my 5/8 into 24ths. So I'm multiplying by something to get 24 in my denominator. I know skate times tree equals dentifloor 24. So I need to multiply by my whole, 3/3, to get 5 times 3 equals 15. And like we said, skate times tree equals dentifloor 24. And now I have two fractions I can compare, 15/24 and 8/24. Go back to the question. We're looking to see which of the following pairs are not equivalent fractions. 8/24 and 15/24 are not the same. I would much rather have 15 pieces of pizza than 8. So these are not equivalent, so I'm guessing that A is probably going to be my answer. So I'm going to put a little star by it, but I still have to check B, C, and D. So let's write B. If we look at the denominators, we have 2/4 and 4/8. Our denominators are not the same, but I notice that I can take the fraction 2/4 and I can change it into something over 8 because I know 4 times 2 equals 8. So if I multiply by a whole, 2/2, 2 times 2 equals 4, and I get 4/8. Now I can compare that to the 4/8 that is in my choice, and 4/8 and 4/8 are equivalent fractions. I'm looking for the one that's not equivalent, so my answer isn't going to be B. Let's look at C. In my denominator, I have 5 and 10. They're not the same, so I need to make them the same. I know I can take my smaller denominator, 5, and turn it into 10. So if I write 3/5 times something equals something over 10, I know 5 times 2 equals 10, so I can multiply by a whole, 2/2. 3 times 2 equals 6, and I get 6/10. When I compare that to my other choice, 6/10, they are equal or equivalent fractions, so it's not going to be C. I have one more to check, that is D. Look at the denominators, 4 and 12. I know I can change 3/4 into 12ths, so I'm going to write 3/4 times something equals, and I'm going to write it down here, something over 12. So I know 4 times 3 would get me to 12. So I can multiply them by my whole, 3 over 3, and 3 times 3 equals line 9. And now I'm comparing 9/12 to the number that's already in 12ths, 9/12, and those are equivalent. So my choice isn't going to be D. So the only pair of fractions that were not equivalent were 1/3 and 5/8 in A, and I figured that out by turning them into 8/24 and 15/24, which are not the same. So your answer is A. All right, one more on this page.
When I was your age, I didn't get to ride no bus to school. I had to walk there, and it was 10 miles away, and it was uphill both ways. And it snowed every single day. Even in June, I walked through the snow.
Number 7 is a writing to explain. It's asking how many fractions are equivalent to 4/5, and we need to explain our answer. So I know to make an equivalent fraction to 4/5, I could multiply it by 2 over 2, and that would get me 8/10, and there's one equivalent fraction. I could multiply that one by 2 over 2 and get 16/20, and that would be an equivalent fraction. I could multiply that by 2 over 2 and get 32/40, and that's an equivalent fraction. And I could keep going again and again and again and multiply that by 2 over 2. Maybe I don't feel like multiplying by 2 over 2. Maybe I want to come back to my original fraction, 4/5, and maybe I want to multiply it by 3 over 3. And I could get an equivalent fraction of 12/15. Maybe I don't want to multiply by 3 over 3. Maybe I want to do 4/5 times 5 over 5 and get 20/25. That would be an equivalent fraction. What if I want to do 4/5 times 100 over 100 and get 400 over 500? I could do that too. There are a million different things that I could do to make an equivalent fraction, and you could probably think of a lot of other ideas of things you can multiply. There are an infinite number of equivalent fractions that you can make because you can just keep multiplying by any whole to find a fraction that's equivalent. So let's put that explanation in words. And let's say there are an infinite. Infinite means infinity. Infinity means it goes on and on and on and on forever and never ever stops. It can be an infinite amount. You can just keep going for the rest of your life, forever, 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 and you can never stop making equivalent fractions. But don't worry, I won't make you do that for the rest of your life. So anyway, there are an infinite number of equivalent fractions to 4/5, and I'm going to write that, but really it's to any fraction, but this question's asking us about 4/5, so I'll write that. There are an infinite number of equivalent fractions to 4/5 because you can multiply it by any whole. So that means you can multiply it by 2 over 2 as many times as you want, or you can multiply it by 3 over 3, or 5 over 5, or 100 over 100, or whatever else you can think of. But you can multiply it by any whole to get an equivalent fraction. All right, one more multiple choice question on the next page. Let's get started.
PSSA? What's a PSSA? We didn't have any PSSA tests. If we had to take a test in school, we had to stand up in front of the whole class and recite our times tables. 1 times 1 equals 1. 1 times 2 equals 2. 3 times 1 equals 3. Did you have to do that? Are we doing that later?
Okay, this problem is a great example of a problem you might see on a PSSA test. So let's work through it together so you know how to tackle this type of question when you get your PSSA. Number 37. In the time it took Gia to run a mile, 5 other miles had run the distances in miles shown below. So Gia ran 1 mile, and some kid ran half of a mile. So they didn't run the whole mile, they only ran part of the mile, while Gia ran the whole. Another kid ran 5/8 of a mile. Another kid ran 3/4 of a mile. And we had 2 kids who ran 7/8 of a mile. Keep reading the question. Which line plot shows the distances in miles the other 5 runners had run? So take a look at our math word wall. Find line plot. It's at coordinate point 11, 1. Remember, line plot is data shown as points on a number line. So if we look at number line A, we have the running distances at the top, and then we have the distances they ran. And then, so this one is showing 1/8 of a mile ran by 1 kid. It shows 2/8 of a mile was ran by no kids. 3/8 of a mile was ran by 1 kid. And we have all of these other line plots that are showing the data. Now, you should notice a problem right away. All of the numbers, it gives us all the top. The denominators, we have 1 denominator in 2, 1 that ends in 8, 1 4, and 2 more in 8. If you look at all of the denominators on the line plot, every single line plot only deals with 8s in the denominator. So we're going to need to change all of our denominators that aren't 8s to 8s and then see which line plot matches. So I'm going to start with the ones that aren't in 8s. So that would be 1/2 and 3/4. Luckily, everything else already is in 8s. Now off to the side, I'm going to start with 1/2. And to turn it into an 8, I need to multiply by something to get something over 8. So I know 2 times 4 equals 8. So if I'm multiplying by a whole, 4 over 4, I could get this as 4/8. So I'm going to cross out my 1/2, and I'm going to change it to 4/8. Now I have to change my 3/4. So I'm going to write 3/4 times something equals something over 8. I know 4 times 2 will get me to 8, so I can multiply by the whole 2 over 2. And 3 times 2 equals 6, so I have 6/8. So I'm going to cross this out and change it. I'm going to have to zoom in here. And I'm going to change this one to 6/8. Now, you'll notice that our numbers are already in order. We have 4/8. Then that 1/2 we're getting rid of because we changed it to 4/8, then 5/8, then 6/8, then 7/8, then 7/8. So now I just need to find the line plot that reflects the data correctly. So if I'm looking at A, I can see right away A has 1/8. It shows 1 kid is running 1/8. If I look at my data, it starts right here at 4/8. So I definitely don't have any 1/8. So that means A is not going to be my answer. So I'm going to cross this out. Now I'm going to look at B. My first one right here starts at 4/8. And I have 1 kid at 4/8. If I look at my data, I do have 1 kid at 4/8 and only 1 kid. So that matches. Back to choice B, I have 1 kid that ran 5/8. And if I look at my data, I have 1 kid that ran 5/8. So that matches. Then I have 6/8. I have 1 kid, or 1x, so that matches there. And then for 7/8, I have 2 kids, and I have 2 kids in my data. So it looks like B could be one of our choices, so let's put a star by it. Let's check C to see if that one's correct. So if I look, I can see I have 1 4/8, which matches my data, 1 5/8 matches the data, 1 6/8, which matches the data, but here I only have 1 7/8, and my data shows that 2 kids ran 7/8. So I know C can't be the choice. One more to check, that would be D. I can see right away that there is 1 kid who ran 3/8, and I don't have a 3/8 in my data at all. So the choice is not going to be D. So that means the only line plot that matches our data is answer choice B. There you go.
Are you kids listening to your teacher? You better listen, because I don't know nothing or any of this nonsense about equivalent fractions or line plots, and you better focus and pay attention so you're smarter than I am when you're my age. Listen up.
Okay, let's take a look at Daily Common Core number 81 together. Turn to the front of your packet. Let's read the problems together and underline important info, and then you can solve on your own. Let's start with number 1. Casey washed 1,028 dishes after lunch. She washed 4,852 dishes after dinner. How many total dishes did she wash? I'm going to bracket my question. I'm looking for the total, which I know could be addition or multiplication. So let's find important info. So Casey and 1,028 dishes. This is part of the dishes that she washed after lunch. And then she did 4,852 dishes. This is part of the dishes that she washed after dinner. So if I have 2 parts, that means I'm going to need to add them together. So that is my total. So go ahead and set that problem up and solve number 1. You can come back to it, but let's take a look at number 2. Find the rule and fill in the missing number. This is a horizontal input-output table. Remember to look from input to output. Draw your arrow. Find the rule and put it in your rule box and fill in your missing part on the output side. Number 3. Carter played outside for 15 minutes. He played with his dog for 5 minutes. Then he rode his bike for 4 minutes. He spent the rest of the time catching bugs. How many minutes did Carter spend catching bugs? So first, bracket the question. We know Carter played outside for 15 minutes. 15 minutes is the total amount of time he was outside. He was with his dog for 5 minutes, so that's part of the time. He rode his bike for 4 minutes, so that's part of the time. And then the rest of the time, he was catching bugs. This is the part, the rest of the time, that's our missing part that we don't know. So we know the total. We have 2 parts that we know and 1 missing part. How can you solve this problem? Number 4 is a line plot. So before I even read the question, I'm going to look at the line plot. I have a length of Jada's worms. I can see that there is 3 inches. There is 1 worm that is 3 inches. There are 3 worms that are 3 1/3 inches long. 2 worms are 3 2/3 inches long. 2 worms are 4 inches long. I have 0 worms that are 4 1/3 inches long, and 4 worms that are 4 2/3 inches long. The question is asking how many of Jaden's worms are less than 4 inches. So here's my 4 right here, my 4 inches. I want to know the length of the worms that are less than 4. So that doesn't include 4. It's everything that's smaller than that. So this is the data that I'm going to look at. I'm going to count that up and choose A, B, C, or D. Number 5, Zoe buys a headband that costs $12. The cashier gives her $8 back in change. How much money did Zoe give the cashier? So first bracket the question. How much money did Zoe give the cashier? we know Zoe, and her headband costs $12. That is going to be my smaller number since she got change back. $8 back is going to be our difference because that's how much change she got back. Change, we know, is a subtraction problem. So we're going to set up bigger minus smaller equals the difference. I know my bigger number is going to be the money she gave the cashier. So this is my missing part that I don't know. The smaller amount of money is $12. That's how much the headband cost. The difference is $8 because that's how much she got back in change. So you have a missing subtraction problem. How can you solve that? The next part is up to you. All right, number 6, draw a quadrilateral that has only one pair of parallel sides. We know a quadrilateral is a polygon with 4 sides, so I'll put a 4 up here. This one pair of parallel sides is a big hint to you. There's only one quadrilateral that has one pair of parallel sides. If you can't remember, take a look at the math word wall to help you. You're going to draw it in that space and then name the quadrilateral. Tell what it is called. All right, that is your Daily Common Core. Finish this page on your own, and then you can move on to your mixed multiplication review.
I seem to have lost my teeth. I lost my dentures, so I'm going to go look for them. You kids finish your Daily Common Core, your mixed multiplication review, then you can do extra math and SC math. Bye.